Alright, so let's take a look at a very common kinematics problem and the typical questions that you'll be asked. So in this problem here, it says a particle P moves along a straight line so that the velocity in meters per second after t seconds is given by, and they give us this velocity function right here, and then also the domain for it. So remember, always make sure you are aware, are you working with velocity or are you working with displacement? And also pay attention to the domain, right, of the variable. Now let's take a look at part A here. And also you're given this graph right here. So basically this is the graph of this velocity function from time 0 to 5. Okay? So in part A here, it says the initial velocity of P. So the initial velocity of P. So whenever they talk about the initial velocity, you have to think that means that the time is equal to 0. Basically, nothing has started. That's why the time is equal to 0, right? So initial means kind of like the starting point. So if the time is equal to 0, there's two ways for you to solve this. You can either plug 0 in for t and then just calculate this on the GDC, or you can graph the function and then just use the table. So since I know I'm going to probably need to graph this for these other parts of the question anyways, I'm just going to graph this on my Inspire. So on the Inspire, it will be graph this. Just go to a blank graph, right? Make sure you are in radian mode, right? You should always be in radian mode, or typically when you're working with calculus problems, and especially when they have a sine, cos, or tan, all right, in the function. So we have 2 times cosine 3x, and then minus, so make sure you're out of the angle spot, so minus 5 times sine x, get out of the angle spot, and then minus 1. Click enter, and then typically, all right, you want to kind of zoom out a little bit, and then I like to do a zoom box after I zoom out so that I see just what I need to see. So pretty much I need to see from 0 to 5. So it was something like this right here, right? So here's our graph. Now I'm gonna find all these kind of key points that we're all gonna need, probably all these maximums, minimums, x-intercepts. So I'm gonna find all of these right now just so I don't have to do it later. So let's see right here. Here's the maximum point. We've got a minimum right here. All right, so that's the minimum. Got another maximum right here. Got a minimum. Here. And we're probably gonna also need these x-intercepts, so I'll find these zeros. There's another 0 right here. All right, so typically these are gonna be the points that we need. Now, what we were looking for is, well, when the time is 0, so you can just go to the table, Control T. We have the table here. Just scroll up. So when the x is 0, all right, the value is 1. All right, so that gives us our answer right there. So we know that, all right, so v of 0 is equal to 1. All right, and then make sure your units are correct. So for velocity, remember the units are meters per second, right? So that's part A. Part B, the displacement of P after 5 seconds. So the displacement, Now we know displacement, right? We have to integrate, right, velocity to get displacement, right? So you have to integrate velocity, right? And then this is going to equal, all right, displacement. And then after 5 seconds. So basically the idea is we're integrating velocity from 0 to 5, right? The velocity function. Okay, so you do this on the calculator. I'm showing you how to do it on the calculator on the Inspire. So let's go to calculate. So menu, calculus, and we're integrating, right? So we're integrating from 0 to 5. And then all you need to do is just type in the velocity function. Okay, so we have 2 times cosine. All right, and then make sure you're in radian. Of course, we're in radian. All right, 3x, and then minus 5 times sine x, and then minus 1. Double check it, make sure everything looks correct. 2 times cosine 3x minus 5 times sine x, then minus 1. Everything looks good. All right, put an x there, and then enter. So we've got our answer there, negative 8.148. So negative 8.148. So this is equal to negative 8.148. Now this is displacement, so the units for displacement is just meters. Okay, let's take a look at part C. Find the distance traveled, right? So distance traveled and total distance traveled, right? This formula is actually in the formula book. So this is when, all right, after 5 seconds. So from 0 to 5, right? Now the formula for total distance traveled is the absolute value, right? Right, you can integrate from 0 to 5, but it's the absolute value of the velocity function. All right, so you notice the difference here. When you just integrate velocity, you get displacement. But if you integrate, right, the absolute value of velocity, this is going to equal the total distance traveled. Okay, so make sure you're aware of these two differences here. Right, so part B and part C, all right, make sure you're completely aware of the difference between the two. Okay, so if you integrate just velocity, that gives you displacement. If you integrate the absolute value of velocity, that is going to give you the total distance traveled. Okay, so we're trying to find total distance traveled, so that's why we're integrating the absolute value of velocity. And once again, we would just do this on the Inspire. So it's pretty much the exact same equation that we type in. We're integrating, all right, from 0 to 5, but it's the absolute value. So make sure you click the absolute value. It's the button right next to the 9. Click absolute value right here, and then type the velocity function. 2 times cosine 3x minus 5 times sine x, and then minus 1. Double check, make sure everything is typed in correctly. It looks like we're good. And then integrating with respect to x, click enter. We get 19.561, right? So 19.561. So 19.561. And the units for total distance traveled is also going to be in meters. Okay, so that's part C. Now part D. So part D here, so it's asking, how many times does P change direction? Okay, now this is where you need to be aware that if you're looking at the velocity graph, right? If we're looking at the velocity graph, that means that the particle is going to change directions, right? If you're looking at a velocity graph, it changes directions when velocity goes from negative to positive or positive to negative, meaning at these spots right here, right? So basically the x-intercepts. So going back to our graph earlier, right? So we go back to our graph earlier. All right, I get out of the table, Control T. So when I graph this, my x-intercepts, right? So we have 0.157 and 3.519, right? So 0.157, so 0.157. So we have t is approximately 0.157, and then t is approximately, if we round the three significant figures, 3.52. 3.52 are seconds, right? This would be seconds. So, all right, when you're looking for change in direction, if you're looking at a velocity graph, you're looking for the, all right, the x-intercepts, okay? Now part E, the acceleration of p after 3 seconds. Now, if we have a velocity and we want to find acceleration, we have to take the derivative. So the derivative of velocity, right, will give us acceleration. So the derivative, all right, t is 3, that will give us the acceleration, all right, at 3 seconds. So on the calculator, we're doing derivative this time. So menu, calculus, derivative. All right, the value is 3, where this is going to be only one derivative, first derivative, right? Just type in our function. We have 2 times cosine 3x minus 5 times sine x, and then minus 1. Double check, everything is typed in correctly. Right, go ahead and click enter. All right, 2.48. So we're going to end up with the acceleration is 2.48, and then we have meters per second squared. So the units for acceleration is meters per second squared. Okay, so 2.48. All right, so let's take a look at some more typical questions that you might be asked, all right, when it comes to kinematics. All right, so let's take a look at question F here. So question F is asking, find the value of t when the particle is at rest. So when the particle is at rest, that means this is when the velocity, right, is equal to 0. So if we're actually working with the velocity graph, so this is actually the velocity graph here. So this represents velocity. So when is the velocity equal to 0? Well, 0 is right here, so it's basically the, right, the x-intercepts, right? So for part F here, right, going back to our graph, I had graphed it on the Inspire. So our x-intercepts were 0.157 and 3.52, right? So the time is approximately 0.157. All right, the particle is at rest, and when it's 3.52, right? 3.52, yeah. All right, seconds. So that's when the particle is at rest, right? So particle is at rest, you want to be thinking velocity is equal to 0, okay? And then in part G here, find the particle's acceleration when its speed, right, is at its greatest. All right, so there's kind of two things we need to think about first. First, we need to find when is the speed at its greatest. So speed, you need to remember, so speed, right, is equal to the absolute value of velocity, okay? So basically think of it this way. If you have the velocity graph, right, if you want to find the greatest speed, it's the highest y value, right, of your graph, ignoring positives and negatives, right? That's why when you absolute value, you can ignore positive or negative because absolute value makes everything positive. So just think, whenever you're asked for the greatest speed, just think, what's the biggest number on the y-axis, okay? So right here, that means we need to find these, look at these maximums and minimums, right? So if I go back to my graph right here, so I had graphed this. So this highest point right here was 5.47, right? The lowest point was negative 7.47. Now the fact that this is negative doesn't matter because we're going to absolute value this, right? So what's the highest, what's the biggest y value, right? Ignoring positives and negatives. It's this 7.47, right? So right here, so when its speed is at the greatest, so basically we're going to find the acceleration. So we're finding acceleration when the speed is the greatest. So the speed is the greatest, right? Right here at 7.47. This is when the speed is the greatest. So what's that x value when this occurs? The x value is 1.160, right? So 1.160, okay? So just to recap, we needed to find when the speed is going to be the greatest. That means what's the biggest y value on the velocity graph. ignoring positive and negative signs. So the biggest positive y value was 5.47, and the biggest negative y value is negative 7.47. So if we ignore this negative here, 7.47 is bigger than 5.47. So this is when the speed, is the greatest. Now we need to find the time, meaning the x value when the speed is the greatest. That's 1.160. Okay, so 1.160, this is the time when the speed is the greatest, and we're finding the acceleration when this occurs. So acceleration, remember, is going to be the derivative of the velocity. This is going to equal the acceleration, right? So we just put this in the calculator. Here, let's go to. So once again, we need to take the derivative. So calculus, derivative, all right? The value is 1.16. We're doing one derivative, first derivative. Just type in the function, 2 times cosine, 2 times cosine, 3x minus 5, times sine x, and then minus 1. All right, double check, make sure everything is typed in correctly. We're in radian mode, everything's good. All right, go ahead and click enter. So we end up with negative 0.00478. All right, 0.00478. So this equals, all right, so negative 0.00478, right? All right, if this is acceleration, the units, all right, meters per second squared. Okay, 478. Well, if you round to 3 significant figures, 479, I guess. Right, 479 if we round to 3 significant figures. All right, so that would be our acceleration when the speed is at its greatest. Okay.